Alrighty. So since there aren't any questions so far from the chat bar or in Remind, I'm going to go ahead and start. Oh, my camera's at a weird angle. I'm going to go ahead and start answering some of the questions from the Google Classroom. All right. So our first question that was asked today was from Kenny. And Kenny asked, when you have the metal and acid and you combine them into a salt, after you've taken out the hydrogen, how do you know which one comes first? For example, how do you know it's CrCl2 and not Cl2Cr? Okay, that goes back to our basic formula writing rules. And we need to remember that our positive ions or our cations will always come first when we're writing a formula. And that's how you know it's CrCl2 and not the other way around. Okay, so that's our first question. Okay, so our next question was from Melanie. And Melanie asked, how can you tell if a compound is a salt just by looking at it? Alrighty, so the thing that you're going to look for is that that compound is ionic. You're going to look for, sorry, let's get some paper. You are going to look and see if you have a metal plus a nonmetal or a metal and let's go over just a little bit, plus a poly or a poly plus a polyatomic. All of those are going to be salts. All right. It's anything ionic is a salt, but your most classic example is the metal plus a nonmetal example, or the metal plus a poly, oftentimes in the case of doing a neutralization. Alrighty, so let's take a look at a couple other questions from the classroom. I've been asked to go over question 21 on page 181 in the review book, and I'm going to do that now. All right, so let's transition over and take a look. So here we've got question 21, and I'm going to just move myself out of the way for just a second and bring that in a little bit. Okay, so question 21 says, what type of reaction occurs when equal volumes of 0.1 molar hydrochloric acid and 0.1 molar sodium hydroxide are mixed? So if we were mixing sodium hydroxide and hydrochloric acid, just going to try changing this, then what we would have is we would have a one-to-one mixture of acid and base. And when we have a one-to-one mixture of acid and base, that would give us a neutralization. Alrighty, let's try another question from the classroom. Ryan asks, are only table J metals capable of reacting with acids? Or is this limitation only to give us a better understanding of the concept? Absolutely. So the metals on table J are not the only ones that are capable of reacting with acids. However, in order to limit it to a reasonable number of metallic elements that are being dealt with in Regents chemistry, we keep that list to the most common metals that one might react with an acid or encounter. All right. There are many, many metals on the reference table that are considered rare or so reactive that the chances of you actually using them in a laboratory setting would be close to nothing. All right, so that's a great question. And let's see. Maria asked about a question on the worksheet on page 29, number 9. She says, I don't know what to do for that one. It's tricky for me. So let's take a moment and look at that question. So page 29, number 9. Okay. So I've already got that one worked out for myself on my page, but so that we are all looking at the same thing, I'm just going to rewrite it really quickly. That's number 9. SR. Oh, lots of people have trouble with this one. And this is once again the reaction of an acid with a metal. Okay. Let's come over. So here is our problem. Okay, this is question 9 from page 29, just rewritten. We have strontium and we have acetic acid. So now in acetic acid, the portion of the acid that is going to be most reactive, or the hydrogen that's going to react with our metal, is this hydrogen right there. Okay, so that being said, this hydrogen is going to be the one that comes over and makes our H2 gas. That means we are left with this portion of the acetic acid. This would be considered the acetate. Okay, now it's going to react with the strontium to form strontium acetate. But because strontium on the reference table has a charge of +2, that means, and this has a charge of -1, the acetate has a charge of -1, that means we have to reverse crisscross. So we have to use a 2 subscript there. I'm going to get rid of those. And in order to be balanced, we would need 2 acetic acids. Alrighty. So I hope that that helped Maria with question 9 on page 29. Alrighty. So let's take a look at, see if we have any. Yeah, Soraya just asked me, Ms. Knoll, do we always have to put into account for diprotic? If you are doing a molarity calculation, okay, if you are doing a molarity calculation, then you have to look at your acid and your base. And if one of them is diprotic or triprotic, you do have to account for that. Okay, but the only time you need to do that, pardon me, is in a molarity calculation. Okay, so let's say you had a diprotic acid, you would multiply your molarity on your acid by 2. If you had a dihydroxy base, you would multiply the concentration or the molarity on your base by 2. But once again, you're only doing that when you're using the titration equation of MAVA equals MBVB. Okay, I hope that helps. So, like phosphoric acid is triprotic, so its concentration would get multiplied by 3. But hydrochloric acid only has 1 hydrogen, so it's monoprotic, so you wouldn't multiply its concentration by anything. Usually on the reagents, they'll only have you do that for one acid or another. I've never seen them, now, once again, the reagents isn't a concern for us now, but I've only seen them use like a diprotic acid and a monohydroxy base. I've never seen them do like triprotic versus like dihydroxy. But that's Okay, so you just asked finding the titration, does that neutralize the solution? Okay, so usually we're doing a titration because we are trying to find the end point to calculate the molarity of either an unknown acid or an unknown base. It depends. So this is kind of a complicated question. Whether you are hitting truly neutral depends on the indicator you are using. Because remember, your endpoint is where the color changes in your indicator. All right. If your color change doesn't happen at neutral, then your endpoint also won't be at neutral. Does that make sense? So technically, when we're using phenolphthalein, our endpoint is around 8, all right, which is slightly basic because phenolphthalein makes its shift between 8 and 9. Alrighty. I hope that answered. So listen, the lab that I assigned, it's actually pretty involved. Don't wait until the last minute to do it, okay? And if you have any questions at all, you can message me at any time and I will help you out. I miss you guys a ton. I hope you really know that. Like, all your teachers miss you, but I'm not there with all your teachers. I'm only in my own head. And I miss you guys a lot. I just wanted you to know that. And listen, I'm trying my best to teach you in a way that makes sense to me and that I hope makes sense to you. But please know, I am always open to suggestions. If there's something you want me to try, some other time you want me to run an event, something you want to see me do, just let me know because I'm totally open to suggestions. So is Ms. Durio. And because we're here for you. If there's something you need, let us know. Okay. That's why we ask that question all the time in our check ins. We really do want to know if there's something that you need. Nicole supports it. Well, I'm glad. Thank you, Nicole. Alrighty. So I'm going to wrap it up for today. Thank you so much for tuning in. We will be running another extra help session tomorrow morning around 10. And be safe, be healthy, be good.